We have this, then we said the derivative for that is going to be your minus 2x dx. Then basically you just have to divide by that minus 2x. This is the same as having minus 1 over 2x du, which is equals to your dx. Then from this, you're going to have what? You're going to have this. You have your x over your u. Then where you see your dx, remember this side we have that dx. Where you see your dx, you replace it by this. You have your 1 over minus 2x du. This cancels this. Then you're left with 1 over u minus 1 over 2 du. Then this minus 1 over 2, you can take it to the other side. Then you're left with 1 over u du. Then that, okay, here we're just going to use the ln rule. Then, yeah, without wasting time, you're going to be left with minus 1 over 2 ln of u plus c. Then you input the right value. You have minus 1 over 2 ln of what's your 1 minus your x squared plus your c. So yeah, that's the final answer for that one. And the second one, let me go and let me check the second one. The second one is b, no, that's e to the exponent minus 3x over 4 plus e to the exponent minus 3x. Okay, I got that. Then it's your e to the exponent minus 3x over your 4 plus your e to the exponent minus 3x. You see? So okay, here you have your dx. Then with this one, I'm trying to check that, okay, which one can I let to be my u? So you see, if in this one you try and let your u be 4 plus e to the exponent minus 3x, then you're basically going to be having a derivative of minus e to the exponent minus 3x. So you already know that you can also take that minus to the other side. You have something which is going to be similar, because if I just say I have my e to the exponent minus 3x bu, it seems like the thing will still not be simplified. I'm still going to be having more complications. So to make it a little bit easier, we're just going to say we let our u be equals to 4 plus our e to the exponent minus 3x. Then you know that your derivative of that is going to be your minus your minus 3e. It's going to be your minus 3e to the exponent minus 3x dx. Then we can just divide by minus 3. This is the same as having minus 1 over 3 du, which is equals to your e to the exponent minus 3x. So now at least there is some light where, yeah, I remember this thing is done a little bit differently like the ones we normally do. So where you see your e to the exponent minus dx by dx, you replace it with this one, basically this part here. You see? So what are we going to have? then just go up. It means now we're going to be having 1 over, remember this one, it's u, 1 over u into your minus 1 over 3 du. Then you can see this minus 1 over 3 is going to be taken to the other side. Then you're left with 1 over u. But like it seems like these ones, you'll just be using the linear rule in most of them. So yeah, you have to make sure you go and check on the Lin rule. Then, okay, forgot the negative sign, it's minus, then yeah, du this side, then you have minus 1 over 3, oh yeah, it's ln of u plus c, then you have minus 1 over 3 ln of what was the u, 4 plus e to the exponent minus 3x plus c. So this would be number b, which is this one. This one we've already done it. Then now we're gonna go to number 3. Let's just see. Okay, then we're gonna go to number 3. Let me just like erase this one. And I want to quickly do this one so that we can get to the e to the exponent 1 minus 2x. I don't know, I feel like this one is, but let me just like do it, since these are also going to be in the exams. We have e to the exponent 1 minus 2x dx. Then we just let our u be equals to 1 minus 2x. Then you know your du is going to be the derivative of 1 minus 2x. Then you know this is going to be minus 2 or dx. Therefore you know your dx, which is the same as having your minus 1 over 2 du. Then you go again and check that, okay, you're going to have what? You're going to have your e to the exponent u. Here you have your minus 1 over 2 du. Then you know the minus 1 over 2 is going to go that side. You're left with e to the exponent u du. Then you know this, you can just like quickly go and write it. And e to the exponent u, this one, it doesn't change. It remains the same thing. You're going to have your e to the exponent u plus c. Then the final answer is minus 1 over 2 e to the exponent, here u is 1 minus 2x plus c. So this will be the final answer. Let's quickly go and check. This is what they got. Then the fourth one, it's your e to the exponent root of x over root of x. Let me just also erase this one. And also guys, I hope you guys are also practicing on your side, or just like attempting them as we're busy doing these things, because now you're about to write. The minutes that you are having now should be the minutes that you are also using to practice. So make sure that like you're using your time properly. Okay, now what do we have? Should I put this thing on the chest? Okay, as I was saying, we have e to the exponent root of x over root of x dx. So even in this one, you see, to simplify this one, we just like have to let our u be equals to our root of x. So these ones, I'm just like doing them faster, just assuming that like you guys, we've been doing these things for long. But like if you feel like you still have some questions, you can just stop me, then we'll explain this thing for you, which is your root of x. And you know this one, can be written in the form, then you have your u is the same as having your x to the exponent 1 over 2. You see? So we know that your du is going to be the derivative of that. The derivative of that is going to be what? You're going to have your 1 over 2, then you have an x, then 1 over 2 minus 1, then you're going to be having a minus 1 over 2. Okay, so this is the same as having what? This is the same as having your du, which is basically your 1 over 2 root of x. But we already said that we're going to let our u be equals to root of x. So it means now on this one we can say our du is the same as having 1 over 2u. Then here I left my dx, then this side still I'm going to be having my dx, then my dx will be equals to, you have your du divided by 1 over 2u. This is the same as having your dx, which is equals to your du multiplied by your 2u over 1. So you know, if you're dividing by 1 over 2u, you can just like flip the sign like that. Then and now what do you have? Remember, you're gonna have e to the exponent u over root of u. Then where you see your dx, you multiply by that du by 2u, and this is going to cancel this. Then now you're left with what? E to the exponent u, your t du. Then you can just take the 2 to the other side, then you have your e to the exponent u du. And still, you know, this one doesn't change, then you can just say you have your t to the exponent u plus c. Then the final answer, you can just say you have your 2 multiplied by e to the exponent root of x plus c. So this is going to be your final answer. Let's go to the top, which is what they got also. Then now we have cos of ln of x over root of x. Then let me quickly erase this. Yeah, I feel like the thing with this, like your integrals and so on, by when you check or look at them, try to at least maybe look. The first thing would be like to determine which one is going to be your u. After determining which one is going to be your u, but like it's just that thing that like the longer you solve these problems, you can just quickly look at the problem in your head, determine which one is going to be you, and also at the same time quickly see where you're going to be having the ones that are going to be cancelling each other. Then after that, you also think about the applicable rule that you're going to be using. You see, like for instance, I'm going to be doing this one. It's just that like it becomes much easier if I have answers like this one. You have something that looks like this. For example, I have x at the bottom and at the top I have my ln of x. So I already know that my u, I'm gonna let it be my ln of x, because the differentiation of ln of x is the same as having your 1 over x. So in my head I know that 1 over x is going to be cancelling with that x at the bottom. You see? So that means I'm going to be left with cos of u. Then cos of u is going to be what? When you find the antiderivative of that, you can just find your sine of ln of x, which is the one that, like I said, is going to be my u, which is exactly the answer that they've got this side. But like, yeah, this is how you just like solve the question without like actually having to write it down. By the time you're going to write it down, you already know all the steps. So what do you have? It was cos it was this. You have your cos of ln of x, then over x, your dx. Then as I said, you look at the top and the bottom, then you let your u be equals to your ln of x. Then you know your differentiation for ln of x is your 1 over x dx. Then you can know that, okay, your dx will be equals to your du divided by 1 over x. Your dx is the same as having your du multiplied by 1 over x. So now it means you have what? You have your cos of u over x. Then you this side you have here I made a mistake. When you're multiplying, this one is going to go at the top, then you're going to have your x over 1. This side we replace the dx with the du, then you're going to have your du multiplied by that x over 1. Then these ones are going to be cancelling one another. Then you're going to be left with what? Going to be this thing is off. You're going to be left with your cos of u du, which is the same as having your sine of u plus c. This is the same as having your sine of ln of x plus c. Then let me check, do we still have some? Yeah, we still have some. Yeah, this one we're done with that one. Then we have this one. Okay. This one, yeah, it's not easy to tell which one is going to be cancelled with which, but just to simplify it, it's just better if you make this internal part be equals to your u. So what do we have? Let me just what is this? It's quickly. Okay, I don't want to cancel that off. Okay, I have that one. Okay, I got it. At least I think I have it. We have my e to the exponent minus x over your 3 plus your e to the exponent minus x. Then this is to the exponent 10. Then you have your dx. Then as I said, in order to make this easier, we can just simplify it by letting this one be our u. Because if you see, you remember this one, if you look at them carefully, this one is similar to which one is similar to this one. Because you look at the one part that, okay, since I'm having something like this, if I'm going to be differentiating one, which one can bring me to the other one? You see this side where we have the 4 plus e to the exponent minus 3x. You remember, because the derivative for that one, it was minus 3e to the exponent minus 3x. Then it meant we had to take the minus to the other side. Then we had something that was common at the top and at the bottom. So even here we're having the same, almost the same thing. I want to do that. We're having almost something similar. Then what do we have? We're going to be having let me just write it here, that we're gonna say let u be equals to our 3 plus our e to the exponent x, then we know that, okay, our du, which is going to be the derivative of that, is going to be minus e to the exponent minus x dx. So it means now we just have to divide by 1. We can just like write, we have our minus du, it's equals to e to the exponent minus x dx. And as I said, this is where you're going to be replacing the part where you see your e to the exponent minus x with your dx, this one with that. So now it means, what are you going to be having? Let me just quickly go down. What are you going to be having? You're going to be having your 1 over Konje. Let me just check again. Okay, we said that one is going to be u. Then it's going to be your u to the exponent 10. Then this side you're only going to be having minus du. Remember, this side, your e to the exponent minus x dx, we only have to replace it with minus du. This is like almost trying to separate the top part. Hence we're having 1 over 10 to the exponent 2. Then we have that minus du to the other side. Then you can see we can just take that minus to the other side, that we have 1 over u to the exponent 10 du. And okay, this one we can also write it like this. We have our u to the exponent minus 10 du. Then you know this side, well, we're going to be using the power rule. So the power rule is going to be saying, what do we have? Let me just write it this side, that we have our u to the exponent n du, which is the same as having our u to the exponent n plus 1 over n plus 1. So from that, what are we going to have? We have minus this, then we're going to be having our u to the exponent minus 9 over minus 9. So this is the same as having what? We can just try to split this one, that we have our 1 over 9. Yeah, minus, I'm sorry about that, minus 1 over 9. Then we have a u to the exponent minus 9. But remember, we still have this minus sign on this other side. So it now means we're going to be having what? We have that minus, then let me just input this in bracket. We have that minus 1 over 9 u to the exponent minus 9. Then the minus and a minus is going to be a plus, which means your final answer is going to be 1 over 9 u to the exponent minus 9 plus c. Then we say we have a 1 over 9. Then our u, it was 3 plus e to the exponent x. 3 plus e to the exponent minus x plus c. So let me quickly check before. I don't think we missed anything.
Sir.
Okay. So yeah, I think we got the correct thing.
Sir.
Yeah. Minus 9.
I think I'm wrong, but I don't know. I did.
You did what?
Hello.
Yeah, I can hear you.
I did learn off the u over 10. Like u to the power of 10, I mean.
Let me check. Then we have minus and On which one?
This one, the one that we're doing now.
Oh, the one for lean, you used lean. We only used lean if perhaps you have 1 over x dx. This is the same as having that one. This is the same as having your ln of x. In this case, it was supposed to be 1 over u du, which is going to be ln of u. But now on this one, we have what? An exponent 1 over u to the exponent 10.
Oh.
Yeah.
Okay.
Yeah, that's the only thing that you missed. You just have to make sure you go back to the rules, then you'll be sorted.
Thank you.
No stress. Then we got that. That will be the final answer for that one, which is which is this one, number F. Number H, yeah, more or less something similar, but let me just quickly erase this one and go to but we are moving 26 minutes already finishing. Means today at least we are on time. Last one. Okay, I think this one is straightforward. What do we have? We have 1 plus e to the exponent minus x over e to the exponent minus x dx. So yeah, it seems like, let me just check, it seems like it's similar to the other one, but not quite really, because this one you can just try to split it before you go and let the top part be your u, because let me just show you something. With this one, you can basically write it that it could be something like this. Then you're gonna have that 1 over e to the exponent minus x plus your e to the exponent minus x over e to the exponent minus x. Then you have your dx. You see? So remember, if I'm having something like this, when I'm gonna bring it to the other side, then it means, what am I trying to say? Okay, yeah, if I'm having something like a 1 over 2 to the exponent minus 2, this is the same as having your 2 to the exponent 2. Hence, with this one, the first part that you see, this side, this one here, you're going to be having your e to the exponent x plus this one, you can see that's your e to the exponent x over e. This one is going to be 1. So now it means you're going to be having that. Then you have your dx. Then this one, you also know that you can do them separately. Then this one, it won't change. You're still going to be having your e to the exponent x plus this one is just going to be x plus your c, which is for this one, then for this one. So it now means you have your e to the exponent. Oh yeah, that's supposed to be the final. And let me just check unless they did it. Oh yeah, that's just supposed to be the final answer. Then we are done with this one. Then we can check this one where they say evaluate. Yeah, I'll also try to at least maybe share one of the final assessment with you guys. But yeah, tomorrow it's Saturday. Linear algebra is not that a lot. We'll probably get like at least maybe a lot of examples to do. But specifically, I feel like, yeah, there's still us that one, which is your simultaneous, I mean. And then the other ones, yeah, they're just like just gonna be straightforward questions. So you have a situation which is going to be like this one. Let me just like get another stylus. Okay. Yeah, then let me check. Yeah. So yeah, we have something like this one. Then oh yeah, these ones are done a little bit differently, because if I remember, okay, let's just leave that part. They're done. I remember, if you remember from the absolute values, we are basically measuring the distance, and your distance with your absolute values, it can never be negative. You see? So if it's like this, the first thing that you have to go and look for is look for whatever that's on the internal, which is going to be this part. You go and look at this, the internal part, that okay, you have your x plus 1 is equals to 0, then your x would be equals to minus 1. You see? So this one is just like your guidance. It just tells you that like your graph is going to be changing at your x is equals to minus 1. I'm just trying to think of an example where I can just like show you how the split happens. Okay. Because like remember, if we're having something like areas, we have to flip them. Okay, let me just use this example that okay, we have a Cartesian plane. Okay, one thing that like I forgot to mention, we have our A and B side. This one, you remember, this one is going to be your A, this one is going to be your B. Then they said here you have your minus 3, this side you have your 3, then the one that we calculated minus 1 adds this side. No, I don't want to write. Why? It. Then exactly here at our minus 1, let me just like highlight it in a different line, that okay, this is where we're going to be having that shift. So since this one is in the negatives or decreasing, let's just say this one is just going to be an area that's going to be in the valley. It's going to be like this. Then the other one, it's going to be one that's in the hill, which is going to be like that. You see, the area that's already in this side, it's positive, and the area that's on this side, it's negative. You see? So the one that we calculated this side, it was just telling us where the path is going to be changing. Remember I said here we just have our hill. This side we can just say we have that valley. So basically what now we're trying to change, we're trying to change this valley to be positive instead of being negative. And you will see if we're trying to find the two areas or the regions, we have to combine them together, but show that like there are two different things when it comes to this -1, because this is where we're going to be having that change in path. Remember the first path that we had, it was this one between -3 to -1. The second path that we had, it was -1 to that +3. You see? So hence you can say in the region where you have your x that's less than -1, then you can conclude that your x plus 1 is it's negative. I'm going to do like this. Yeah, it's negative, hence you can see with the values that it's negative. Then where we have our x as greater or equals to -1, which is basically this region, you can tell that it's positive. It's positive. Then this one that like I want to highlight, this is the one that's negative, and as we said, we can't be measuring a distance that's negative. So hence in this region we're gonna see, what do we have? We have an absolute value of x plus 1, which is equals to that x plus 1, but now we have to introduce this minus sign, because this one is to what? Is to flip the area and make sure that like it's positive. You see? So it now means you're going to be having two different things at the two regions. This one that you see here, it will be at the region between -3 to -1. Then the x plus 1, which is still positive, this one is going to be from -1 to +3. So yeah, this is exactly where we're going to be having that change of path. And like as I've explained, this is how the thing is going to be like. So now we have to interpret these two statements. Remember, this is the first part, which is that -3 to -1. Then this will be the second part. You have to add these two together. So what did we have at the top? At the top we had an integral of 3, then this side we had -3, then in between we had x minus 1, then dx. See? So this is the same as having what? An integral between those first region that like we've chosen. We've chosen, it was what? It was -3 and -1. The biggest one is -1. Then this side we're going to be having that -3. Then we have x minus 1, your dx, plus the other one on the other side, which is going to be your 3 and -1. Then we have that x minus 1 dx. Then we come again, remember with the explanation that we have this side that like we are flipping the region that's going to be negative to ensure that it's going to be positive. Hence you see this negative sign being introduced. So it now means I think I can even also just like write it on this one. It now means you're going to be having that sign this side, you know, going to be having that region that side. Then now
is the absolute function not x plus 1?
Is it x plus 1 or oh yeah, excuse, let me just quickly go and check. Oh, x plus 1, sorry for that. Which means I've made mistakes this side. Minus 3 to 1. Then the other one. Okay, let me quickly relax. We have minus the region, minus 3 to minus 1. Then we have minus. No, man. Why do I keep on saying, man? We had plus x plus 1. Oh, yeah, that one is correct. We're still going to be having that minus 1. From what we've solved, this side. From what we've solved, this side is going to be between minus 3, or that region minus 3 to minus 1. Then the second one is going to be minus 1 to 3, which is going to be this region as I've indicated. Then the only region that like we're trying to make to be positive, it will be this region in red. Hence, now I've introduced this negative sign here. Then here was just starting with the thing that, okay, on the first one we have minus 3 and minus 1. I think they were correct. We have minus no man. So yeah, this side we have x plus 1 dx, then we still have the x plus 1 dx. Okay, I have to write the b and a. The b for this first one, which is going to be this one. The bigger one will be minus 1. Then this side we're going to be having minus 3. Then when we come to the second one, the bigger one is going to be 3. Then this side we're going to be having minus 1. Then and now we have to find the antiderivative of our x plus 1. We know this one, we can quickly just write it that, okay, we have our x dx plus 1 dx. Remember, this can be written as your x to the exponent 1, hence we're going to be using the power rule. This will be seen as what? This will be seen as your x squared over 2 plus your x. So you still remember the power rule, that you have your x to the exponent n plus 1 over n plus 1. This is basically what I'm doing at this side, you see. So okay, let's write that one again at the top. That what do we have? We have this let me just write it in a way that it's going to be faster. We have our x squared over 2 plus x. Then the first region is between minus 1, minus 3, plus we still have the x squared over 2 plus x. Then this side we're going to be having the 3 and 1. Going to have the 3 and minus 1. So which means now we're going to be having minus 1 squared over 2 plus into minus 1 minus into minus 3 then we have minus 3 squared over 2 plus into minus 3. then plus for the other part. What are we going to have? We're going to have 3 squared over 2 plus into 3 minus into minus 1 squared over 2 plus into minus 1. So yeah, just to recap, guys, remember the moment we start to use the after finding the antiderivative, we always go back and use the fundamental theorem. The fundamental theorem, what does it say? The fundamental theorem, it says you always have your f of b minus your f of a, which is what we've got. This would be after you've got your antiderivative. So basically we're just like inputting our a and b's into the equation. So where am I getting my a and b's? This at the top, this is where you're going to get your a, your b and a. This is your b, this is your a. So these values also that you're seeing here, these are the ones, these are the ones that like I'm inputting your -1 and your -3. For the first one, or the first part, it was for this one. So these things are split into 2. The second part, which is this one, let me just show you. The one in yellow, that's this one. And the second one, it's going to be the one in blue. It's going to be this one, which is going to be this one. Hence you can see where I've started with the 3 this side. Here this side I've started with those -1. So that will be that. Did anyone manage to get the answer of the final answer for those two? But I'll just screenshot it also. Then yeah, we're done with those questions that were asked. Let me just quickly check this thing when you're also trying to check the final answer. Remember here it's a +1. Sorry for cancelling that. So you get the first answer for this one, then you add it to this one, then you get the answer for this one. Let me check something when you're still busy calculating. Sorry about that. Let me do this.
The first half, the one for 3, the answer is 7.5.
It's 7.5.
Yeah.
And 7.5, the other one.
And then for the other one, do I add the minus when I calculate the other part?
You add the minus, what do you mean? You mean this one in the middle?
Yeah.
Yeah, remember this one, as I've explained, you have your f of b minus a. You did the first one for this one at the top,
Yeah.
then even at the bottom you do something which is similar.
Okay, then the second half is 0.5.
That's 0.5. 0.5, then that means here you're going to be getting your your 8. I'm just trying to check another question that we can do on the other thing. What's my summary book? Because I said we have to do reverse the first derivative or the second derivative. Then what else? Okay. Yeah, because it's also there in the unit 7. Because like you've seen, last time we were doing this example, they were kept on talking about maximizing. The moment you start to see the words maximizing, you know that they are referring to the thing. They are referring to the first derivative. Hence, that's why I wanted to also talk about the first derivative test. I know that side it's done a little bit different at the top, but the other step is just the same ones. I'm just trying to look for an example this side. Okay, I think yeah, I do see it in the red book that like I have it with me. Use the first derivative. Use. Oh, I see one example. Then yeah, let's just quickly go and check. With this one we are done. Wait. I think we missed something here. You see where we had the minus sign in red, we didn't include it in our formula for the first one, where we had minus 1 and minus 3. Minus 1 and minus 3. So let me quickly check. The first one is minus 1 and minus 3. I said it's 3 and 1. Yeah, we made minus 1 and minus 3. Oh, here I did it correctly. Let's just make sure that we fix this. We have minus 3 and minus 3. Then at this side we're just going to put minus. Let me just show it in red. And this side is going to be, well, no, not the second one, the first one. Yeah, that's the one. Why am I confusing myself today? We have this one, which is the first one, which means also I have to have it here. I'm following this one that like we've written this side. So we're going to have it this side. Then we said we have our minus 1 and minus 3. Then okay. Then the second one, yeah, that's between 3 and 1. Which is something like that. I don't know. Oh yeah, I think you guys will just like find the answer for that one, just so that we don't waste